This video is for class 8 physics, and in this video we are solving the remaining numerical problems from the chapter energy. In the previous two videos, that is part 1 and part 2, we have solved till question number 7. In this video we are solving from question number 8. So in this video we shall do these three sums, number 8, number 9 and number 10, and the remaining sums will be completed in the last part of the video, which will be part 4. So let us start. Going to question number 8, it reads as a body of mass 60 kg, so mass given to us is 60 kg, mass given to us is 60 kg, is moving with the speed of 50 meter per second. So speed is also given, which I denote it by v. So find its kinetic energy. Now this is a direct problem where I can use the formula of kinetic energy, which is equal to half mass into velocity or speed square. Okay, now let us go to its solution. So coming to the solution of number 8, where mass given to us is 60 kg, speed given to us is 50 meter per second. So as both are in the SI unit, so no need to convert also. So now kinetic energy equals to half mv square. So kinetic energy equals to half mv square. So using the formula I can further solve it as kinetic energy equals to half m's value is 60 kg and v square becomes 50 meter per second whole square. Okay, now further solving it, we shall get kinetic energy equals to half multiplied by 60 kg into 50 meter per second into 50 meter per second. So these two can cancel, this 2 can be cancelled by 2, and this 60 also can be cancelled by 2. So 2 one time is 2 and 2 30 times is 60. Now multiplying the remaining numbers, which is 30 multiplied by 50 multiplied by 50, so I shall get 75,000, right? And as you all know, the unit of energy is joules, so I have put J there. Now or kinetic energy equals to 7.5 into 10 to the power 4 joule. Okay, we can represent this 75,000 in terms of the powers of 10, okay, by simply putting a decimal point after one digit, right? So after one digit, so decimal point here, and the remaining will be counted in the powers of 10, so which is 1 2 3 zeros, and as this 5 comes behind the decimal point, so this also will be counted as 1, so it will be 10 to the power 4 joule. So I can put 4 as the power. I hope you have understood number 8. Now let us go to question number 9. Question number 9 reads as a truck of mass 1000 kg, right? A truck of mass 1000 kilogram increases its speed from 36 kilometer per hour to 72 kilometer per hour. So two speeds are given to us, which is 36 kilometer per hour and 72 kilometer per hour. So here we are supposed to find the increase in its kinetic energy. So if the speed changes, you all know that the kinetic energy also should change. So here the speed is increasing, so kinetic energy also should increase. By how much we have to calculate. Okay, let us go to its solution. So coming to the solution of number 9, given mass is 1000 kg, right? So the first speed given to us was 36 kilometer per hour. So here what happens is kilometer is not the SI unit of distance. So an hour is also not the SI unit of time. So what happens is we are supposed to convert this kilometer per hour into meter per second. I think we have learned this in class 7 also. Let us revise. So now here the number 36 is given. So what I have written is, I have written 36 multiplied by 1000. So why am I multiplying it by 1000? Because 1 kilometer has 1000 meter. 1 kilometer has 1000 meter, right? Now what can I do is, now there is one unit for time also, which is hour. So hour need to be get converted into seconds. So 60 multiplied by 60. 160 is for minutes and the other 60 is for seconds. So now hence I am getting 36 into 1000 upon 60 into 60. Now let us see the cancellation. This 0 can cancel this 0, this 0 can cancel this 0, right? Now this 6 can cancel this 36 6 times, and this 6 also can be cancelled by this 6, right? So the remaining number here for us is 10. The remaining number is 10, right? Hence we shall get 10 meter per second. Hence we shall get 10 meter per second. I hope you have understood till here. Now similarly, the second speed which is given to us, which is v2, is 72 km per hour. This 72 also needs to get converted into meter per second. I have done the same calculation, same method I have applied here also. So 72 multiplied by 1000 upon 60 into 60. And then further cancelling it, I shall get 20 meter per second. Please try to cancel by yourself. Here also I have cancelled 0 and 0. Right, here also I have cancelled the numbers. Okay, so after cancellation and then multiplication, we shall get 20 meter per second. Now with the help of this mass, this first speed and this second speed, we shall get two kinetic energies. V1 will give me first kinetic energy and V2 shall give me second kinetic energy, and when we subtract them, we shall get the increase in the kinetic energy. So let us further solve it. So initial kinetic energy, that is first kinetic energy, that is K1, should be equals to half m V1 square, right? So K1 will be equals to half multiplied by m, which was 1000, multiplied by V1 square, which is 10 multiplied by 10, because the value of V1 was calculated to be 10. Now cancellation, okay, 2 1 times 2, 2 5 times 10. Okay, now only the numbers are left. So if I multiply, I shall get 50,000 joule. After multiplication, I am getting 50,000 joule. That is the value of the first kinetic energy or the initial kinetic energy. Now I am calculating the final kinetic energy. Okay, that is K2, last kinetic energy, the second kinetic energy, which is equal to half m V2 square. Replacing the values of m and V2, that is half multiplied by 1000 multiplied by 20 into 20. Half multiplied by 1000 multiplied by 20 into 20. So 2 1 times is 2, 2 10 times is 20. So if I multiply these three numbers, I shall get 2 lakh. Okay, I shall get 2 lakh joule, right? I shall get 2 lakh joule. Okay, so now increase in the kinetic energy. To find the increase, we are supposed to subtract the lesser value from the bigger value. So what I have done is, I have done 2 lakh minus 50,000. So here I have written here I have written 2 lakh minus 50,000. So after subtracting, I shall get 1 lakh 50,000 joules. 1 lakh 50,000 joules here. Okay, so this is our answer of number 9. Let us go to the last sum, which is number 10 for this video. Coming to the last question of this video, which is number 10. A car is moving with the speed of 15 km per hour. A car is moving the speed of 15 km per hour. So speed is given to us. And another identical car, same car, okay, same kind of car, that means the mass is same. So if it is identical car, so mass remains same. So mass of both the cars is same. Mass is same in this case, right? Identical car is moving with the speed of 30 km per hour. So again, we have given two speeds, that is V1 and V2. Compare their kinetic energy. Okay, I am supposed to compare their kinetic energy. As you all know, when the word compare comes, we need to find the answer in the ratio form or in the fraction form. Okay, let us try to solve this. So coming to the solution of number 10. Number 10, given, right, first car and the second car. The first car's speed is 15 km per hour and the second car's speed is 30 km per hour, right? So let the mass of the two identical cars be m. So since they are identical, so they will have same mass, that is m. Then therefore the kinetic energy of the first car k1 equals to half mv1 square, which is half m 15 km per hour into 15 km per hour. Now you must be wondering why I haven't changed the unit, because the unit of mass was not given to us. Okay, in the previous sum the unit of mass was given, which is kilogram, whereas the unit of speed was in kilometer per hour, which was not matching. Here, since there is only one unit, which is kilometer per hour, hence I am not changing the unit. And ultimately in the case of comparison, the units and the numbers gets cancelled, so therefore I am not changing the unit in this sum. Right now, kinetic energy of the second car, I am not calculating also, I am not multiplying also, because they can get cancelled. I am not multiplying all this right now. So kinetic energy of the second car, which is k2 equals to half mv2 square. So k2 equals to half into m into 30 km per hour multiplied by 30 km per hour. Okay, now comparing these two kinetic energies, that is k1 upon k2. So k1's value was half m 15 multiplied by 15, right? And k2's value is half m 30 multiplied by 30. Okay, so here you can see kilometer per hour cancels, kilometer per hour also gets cancelled, m and m also gets cancelled, right? So this half and half is also getting cancelled. 15 1 times 15, 15 2 times 30, 15 1 times 15, 15 2 times is 30. Hence the upper number is, that is all have been cancelled, so I have remained with 1 into 1 into 1, right? That is 1. And the lower value, that is the denominator's value, is 2 into 2, which is 4. So hence after comparison I am getting 1 upon 4, which can be written in the ratio format, which is k1 is to k2 should be equals to 1 is to 4. So remember here the first quantity should be compared with the second quantity. It's not k2 upon k1, it has to be k1 upon k2. Okay, I hope you understood number 10 also. Thank you so much.